Yes, class. This is audible to both of you. Salman, Khalid.
Yes, ma'am.
Assalamualaikum teacher. Yes,
Walaikum
it's
assalam.
audible.
Alright. So in this last class, we had started with series and parallel combination of resistors. So in series combination, you just have to add all of them directly to get the equivalent resistance. R1, R2, R3, R4, n number of resistors are connected, just directly keep on adding them. If you have the connection in parallel, then you have to reciprocally add them. 1 by R equivalent is 1 by R1 plus 1 by R2 up till 1 by Rn in this way. So basic circuits we have already covered. Salman, this is your school's test paper.
Yeah, today we had like unit test.
You had a unit test, and what was the syllabus?
It was 2 chapters.
First and second.
Yeah, first and second. Yeah.
All. Meanwhile, I'm seeing the paper. You people try with this circuit. Few circuits let's discuss, because capacitors we had seen few circuits, but your circuits are a part of your syllabus, major part of your these first and second and the third chapter. So let's discuss some circuits. One circuit you also have that we haven't done in capacitor one, infinitely long case. So let's practice few circuits of resistors connected together. So how did your paper go, Salman?
It went smooth, it was easy.
It was fine. And Khalid, you are also in the same school, no? So you must also be having your paper today.
Yeah, we
Yeah,
had the
the
same paper.
paper was easy.
Easy. It was easy. Okay, good then. So how does this unit test occur in your school? Means consecutively, like the way exams occur, Monday, Tuesday, Wednesday, in this manner, or weekly?
Consequently.
Okay. So calculate the equivalent resistance in this circuit. Shravya, I've seen your assignment. So you've completed all the assignments. So no assignment is pending. So I'm not giving new assignments this week because many students of your batch, they haven't completed that. So others, please try to submit the assignment. If you have not received, just ask me. I'll share it on the screen and then you can see. Shravya, one more thing I wanted to ask. Are you people attending those extra classes for JEE and NEET? I think Shravya, you were attending, no? Yes, you were attending. The classes timings was getting coincided with it, whatever timings, because you have missed your classes also here. So, Shraddha, tell me, did you study? It is at 7:30, 1.5 hours class, no? So, Shraddha, tell me one thing. How much did you cover till here? First chapter was done. I think potential and capacitance. Complete chapter has been missed, no? Yes. So, Shravya, I would suggest you to join Tuesday, Thursday's batch at the same timing, 6:30. We are having different batches. No, one batch is on Monday, Wednesday. Then we have another batch on Tuesday, Thursday. There also we have a batch at 4 o'clock. Another batch is at same timing, 6:30. So I think you should join that batch, because in that batch we have just started with potential, and few classes of current which you have already done here, it can be stopped. So I think you must be having your chemistry classes on Tuesday, Thursday right now. That can be shifted on Monday and Wednesday. So if you shift to that batch, your chemistry classes will be on Monday and Wednesday, and then your physics classes will be there at. You're okay with that chapter? All right. If you're having any issues, or if you wish to do it again, okay, you had it in your unit test. Fine. So your paper questions are easy. Those questions seem easy, direct derivation and all the numericals we have already discussed in class. I was asking whether it was lengthy or not because it is looking as if it is
It was.
It was
It
lengthy, no?
was. Yeah. We. I think we both finished almost at the end of the time.
At the end of time, yes, it was looking very lengthy. What is the duration? I didn't see. 20 marks paper
1
and
hour.
1 hour.
1 hour.
duration.
1 hour.
1 hour. Yes, Salman, your answer is right. Correct answer. See, both these resistors, these are divided by branching because of this wire. It means branching has occurred that will divide the current and the potential remains the same. It means, let's name them 1, 2, 3, 4, 5, and 6. So 1 and 2, these are connected in parallel. Now, one trick to remember to ease your calculations because so many resistors will be given to you. So, one trick that you should remember is if the two resistors are identical, they directly take the half of it. Means the sum, the answer equivalent resistance of 1 and 2, you can directly take it as R by 2 if they are identical. If they are unidentical, then no need to do. Then you have to perform the whole calculation 1 by R equivalent. Now, how does the circuit look like? This is 5, 6, 4, 3, and this is 1, 2. R12 has been combined. All are having the value capital R. Now, if you look at both these, they are connected by a single wire. It means they are connected in which manner? Series or parallel? Series. So R12 and R3, these are connected in series. So in series, you have to directly add them. This is R by 2. So it becomes R by 2 plus R. So this is 2R plus R. This is 3R divided by 2. Now, how does your circuit look like? Here it is R, here it is R, and instead we have 3R by 2 over here. Yes, good. Khalid, your answer is also right. This is between A and B. Now, if you look at 3R by 2 and R by 2, both of these are connected in again parallel combination is there. So this was R1, 2, 3, 4. If I R1, 2, 3. This is R1, 2, 3. This is 4, 5, and 6. So if these are connected in parallel, just simply take the reciprocal of it. R1, 2, 3, 4 will be what? 1 by R plus 2 by 3R. So 1 by R, 1, 2, 3, 4, this becomes 3 plus 2 divided by 3R. That is 5 by 3R. So R, 1, 2, 3, 4, this becomes, how much we have? 3R by 5. Now we have to find out the net resistance. Net resistance means equivalent resistance. So this is fifth one, which is having the value R. This is the sixth one, which is having the value R. Here R1, 2, 3, 4 is there, which is having the value 3R by 5. Now you can see all these three, these are connected in series. All these three. These are just connected by single wire, so they are connected in series. Simply just add them. R equivalent will be what? R plus 3R by 5. 3R by 5. So this becomes 5R plus 5R plus 3R by 5. So R equivalent is basically 13R by 5. All right, so note it down, and we'll do infinitely connected resistors. If you have resistors which are connected, but their number is infinite. So obviously it's not possible to calculate the equal resistance by adding each of them. So there's a trick for infinitely connected resistors, and that is same valid for capacitors. Now, the case of infinite series. So we cannot just directly do it without the help of an example. So let's take an example over here. Let's say this is 1 ohm. Let's take it as 2. It's all right. Now this will be 1 ohm. Here you will be having 2 ohms. Again, you will be having 1 ohm, you will be having 2 ohm, and all these will be connected till infinity. 1 ohm and 2. So if you are asked to calculate the equivalent resistance between A and B, no, then the first step is to identify which series is getting repeated. If I tell you about the first step, you have to identify the repeating terms. Which terms are getting repeated? Repeating term means which are the infinite terms. In this, if you see this is again getting repeated. This is again getting repeated. It means till infinity, this is connected till in this manner. So first step was to identify it. Then assume that the whole net equivalent resistance of all these infinite series is capital R. Capital R is what? Capital R is the net equivalent resistance. Means your answer is capital R. So first let's assume that the whole equivalent resistance, step 2, that the equivalent resistance, just assume that R equivalent is R. R equivalent means for the whole series it is R. For whole series that we are calculating, it is smaller, capital R. Step 3. Now see, if all these series are repeating, all the infinite series are getting repeated, if I add one more series to it, will there be any difference in my answer? Capital R is already there. That I know. Capital R I have assumed. Capital R is what? Capital R is all the sum of equivalent resistance of all the resistors which were connected in infinitely series. That was capital R. Now, if I add one more series, just one. This was 1 ohm, this was 2 ohms to this capital R. Will there be any effect on the net equivalent resistance? See, if I add, I was having infinity. I just added 1 to infinity. Can't you say infinity plus 1? This is almost equal to infinity. Even if so many circuits were there, even if you're adding. Yes. So I can say that the net equivalent resistance of this circuit that I have drawn right now, this will still be equal to R. And what is my aim? I have to calculate capital R only. This is my aim. I just have to calculate capital R. Why? Capital R is the infinitely resistors connected together. So it means, let's say this is A, this is B. One more circuit I have added because I know there won't be any effect on my answer. And capital R is the net equivalent resistance that is already there. So step 3 becomes what? Just add one more repeating term, means the repetition term that you have identified. Add one more repetition term. Why? Because equivalent resistance should remain the same. Reason is that R equivalent should remain the same. So it means if I have, now I'm considering these as 3 independent resistors. So this is 1, this is 2, this is 3. 3 resistors I have. Now I have to solve this circuit. So by now we are almost at this point that we'll be able to solve these circuits. We should be able to solve all these circuits. Now, if you see this, capital R and 2, both of these are connected in which order? Series or parallel?
Parallel.
These are connected in parallel, exactly. And their net resistance, means whatever is parallel, this is connected in series with it. So firstly, let us identify what is this R12. Now see, both of them are having different values. Had it been 2, 2, we would have written 1. Had it been capital R, we would have written it capital R by 2. So here we'll be writing R by 2. Not R by 2, we'll be actually solving it. So this becomes what? R12. This is connected in what? Parallel. So 1 by R12 becomes 1 by 2 plus 1 by capital R. So their LCM is 2R. That becomes 2 plus R divided by 2R. So R12 is what? This is 2R divided by 2 plus capital R. So I have the value of capital R. Now how does the circuit look like? Circuit has been shortened and it looks like this was 1 ohm. This was, initially it was 2 ohms, but now it is 2R by 2 plus R. This was A, this was B. Now if you see both of them, both these are connected in which manner? Series or parallel? Series. They are connected in series. Yes, yes. Good, Khalid. It is connected in series. So R12 and R3, these are connected in series. It means I can directly add them. Now, if I directly add the series R12 plus R3, so see, it will be what? I just have to R2R plus 2 plus R plus 1 ohms. Now, the net or the equivalent resistance of this whole circuit, 2R plus 2R divided by 2 plus R and 1 ohm, the equivalent resistance of this circuit, this will be still equal to the equivalent resistance of our infinite series, because as discussed earlier, whatever is the equivalent resistance, it won't be having any effect if we add the repeating term. So it means this net equivalent resistance, this will still be equal to capital R. Capital R, why? Because capital R was our infinitely seriesing term. So even if I had added one more term by myself, the answer didn't change. If I am assuming that the net or equivalent resistance of this whole circuit is capital R, on adding this repeating term, that the answer, final answer will still be capital R only. That's why I can add this R in the final answer after solving. First step was what? To identify whatever was your repeating term, repeating term or a repeating term which was occurring in the infinite series. Firstly, identify that. Once you have identified that term, then you can add it with the whole infinite series, and whatever answer you get, that will be still equal to the infinite term. So this will still be equal to capital R. Now you can take the LCM first. So LCM will be 2 plus R divided by 2 plus R equal to capital R. Try to solve it till here. Just wait for 2 minutes. And how did your exam go, Zed?
Well, it was very good.
It went fine, no? Okay, good. So Monday you came, but I think you were not able to connect your audio because I called out your name.
Yes.
Issues in network, no? All right.
Yes.
So if we solve this further, this becomes 3r plus 2 divided by 2 plus r. This is equal to capital R. So let's cross multiply it. Means this will be 3r plus 2 and this side will be having r multiplied by 2 plus r. So let's open the brackets. 3r plus 2, this will be equal to 2r plus r square. 2 plus 3r, this will be equal to r square. So if let's transport it in terms of this side. 0 will be equal to, this is 2r, this will be equal to plus r square. This, or both these terms will become minus 2 minus 3r. So 0 will be equal to 2r, not 2r, this will become minus r. 2r minus 3r, this will become minus r. So it is r square minus r square minus r and minus 2. Now to solve this, we can use splitting the middle term. Otherwise, this quadratic equation cannot be solved. Either you can use that whole long equation, or this is very easy one. So you can split the middle term. So this can be, so you have to choose one of them. Shravya, both the values will come, but you have to choose one of them. See which one will be the answer. Both the values cannot be the answer of it. So this will be 0. You're telling me the values of this. Okay, yes, Khalid is right. So this will be equal to r square minus 2r for this and plus r. Okay, you were telling me for this means 2 and 1. Okay, that is right then. Minus 2, this will be equal to 0. So if you take r common from here, this becomes r minus 2. And if you take plus 1 common from here, then also it becomes r minus 2 from here. So which values you have? You have r minus 2 with you and r plus 1 with you. So from here, r minus 2, r will be equal to 2 ohms. And from here, r will be equal to minus 1 ohm. See, resistance cannot be negative. It will be 2. Yes, we had to choose between these values. We have to choose between these. See, resistance cannot be negative. The way if you get some equations where time is coming negative, so that shows that time cannot be negative. So similarly, in this also, you will see that resistance cannot be negative. So it means your final answer of the whole circuit is 2 ohms. So this is your whole answer of infinitely connected circuits. All right, so note down this portion as well, then we'll do some more circuits we'll see. I think here you all have written. one more thing I wanted to ask you people, those extra classes that you are having for JEE and NEET, most of the timings are getting clashed. The way Shravya you have mentioned that 7:30 is the timing, I believe. So instead of that, if the timings are from 8:30, KSA timings, 8:30, then is it fine for you people, even for those who are not taking the classes? And it might happen that you will take the class further. So is 8:30 KSA time, 8:30 fine for you all people? So just text me in the chat, yes or no, all four of you. If it's fine for you, then you will, because most of the classes get over by around 8 o'clock. So you will be having a half an hour gap, and 8:30 from you can have the classes. So if the classes are from 8:30, you have only 2 days getting clocked. So few students are in favor of it, few students aren't in favor of it. So it's better if I know the opinion of all four of you as well. So
Sure, like changing the timing or
not of this
extra class.
batch. Extra class, not of this batch. No, our timings are fixed, not of this batch. The extra classes that you people are having, JEE and NEET classes. If it's fine, just write yes or no in the chat box. Because Shavya, I had seen taking one class. Others, I am not aware of who are all are taking, who are not taking. So even if you're not taking, just if it's fine by you, then the way Zaid has mentioned. So others also just write a yes or a no. Not possible for you. Okay. Others also respond. Khalid and Salman, you also tell me. If
Again,
it's
ma'am, what is...
remember I announced about some classes,
Yeah.
those extra classes about JEE and NEET, which
Yeah.
you people are having twice a week. So for many students, the timings are getting clashed with their normal classes, like
Okay.
these classes. So if the timings are from 8:30, okay, so your timings, then is it fine for you people? Like if it's fine, then write yes, and if you think it's too late for you, then just
8:30
write
p.m.
yes, 8:30 p.m. All right. Also, who all are taking, by the way, Shravya, I know, among Zaid, Salman, and Khalid, are you people taking or not those classes?
No, I ain't taken.
Well,
Even
not
Khalid,
yet.
we also don't.
All the voices got mixed. Yes, Zaid, you are taking?
Well, not yet.
Not yet. Not yet. And what about Khalid, you?
No, teacher.
And Salman?
Yeah.
Not yet. Okay. Shravya, you tell me, are you satisfied with the faculty, sir, who was teaching you? Because just tell me, or do you want the faculty to get changed? Whoever was teaching you those classes, one sir was taking those extra classes. So now Azam sir himself will be taking those classes. So if you were having issues with the faculty, now sir himself will take. So you people also can have a trial class with him. All right. So one more circuits, let's discuss it. Okay, sir's voice, because of his network issue, or he speaks very slowly, or what? All right, Salman. Okay, Shravya. It's a bit feeble. All right. So now Azam sir himself will be taking the classes. So I think you all will be benefiting from it. So just have a class with him, then see, and we'll tell you about the timings as well.
Ma'am, is it coming 20?
The R equivalent, no, for the whole circuit? Yes, yes.
Yes.
Good, good. Who has answered this? Zed.
Yes.
It's correct. It is 20. Someone else has. Okay, okay, Salman. Okay, Salman. If you people are, you must be having your namaz time there, no? So, fine. You can go pray and come. Some error, Khalid. Just check once again. There must be errors in your calculation, I think. See, if we name these, let's say this is 1, this is 2, this is 3, this is 4. So you can easily see regarding 1 and 2. 1 and 2 are connected in which order? 1 and 2 are connected in series. Similarly, 3 and 4, both of these are also connected in series. So R12 is connected in series. So it was what? 10 and 20, I think. 10 and 20. So R1 and R2, these are connected in series. So it becomes 10 plus 20, that is 30 ohms. Then R3 and R4 are also connected in series. This becomes R34, which was, the value was what? 20 and 40. Wheatstone bridge can be applied. Yes, yes, directly Wheatstone bridge can be applied. First, we have to check the balancing condition. So here, both of them are having the value half, no? 10 and 20 and 20 and 40. Yes, yes. So you can apply the concept of Wheatstone bridge. Balanced Wheatstone bridge, you can apply. If it's unbalanced Wheatstone bridge, then you cannot apply. So then for that, you have Kirchhoff's law that we'll discuss. Now it's correct, Khalid. Now it's right. So R34 is what? This is 20 plus 40, which is equal to 60 ohms. Now, if you see their resultant, both of these are connected in parallel. R12 and R34, both of these are connected in parallel. So you have to find out the equivalent resistance between these two. R equivalent will be what? 1 by R12 plus 1 by R34. This will be the equivalent resistance. One is having the value 30, other one is having the value 60. Yes, that's right. So this will be what? 1 by R equivalent becomes 1 by 30 plus 1 by 60, which is 60, and you have 3. So this becomes 1 by 20, and R equivalent becomes what? 20. All right. So those who haven't written, just note it. Which chapter is currently going in your school, Zaid?
My fourth one, magnetism.
magnetic effects after current electricity is done.
Yes.
And Khalid is there right now. He has left for namaz. Khalid, are you there in the class? Both of them have left.
Yes,
And Khalid, you there? Yes. What is the syllabus currently going in physics in your school? Which
now we are
chapter?
doing current electricity.
Current electricity. All right. And Shavya, what about you? Okay, magnetic effects. Fine. Chapter 4. Yes, Salman. 5/3. That is correct for the first one. Just for your confusion, this is A and this is B. So across A and B, you have to calculate.
Ma'am, for second, is it coming 31?
For second one, no?
Yes.
Yes, that's right. For the first one, Zeb, any answers?
Yes, ma'am. I got same like 3/5. I think 5/3.
3/5. Just check. Just check.
Okay.
We'll discuss it. One last minute, and we'll discuss. Second part is right, Shabir. Let's discuss the first part, and I think some of you are having issues in the first part. See,
Ma'am, my second part is correct.
yes, Salman, your both parts are both the parts are correct,
Okay.
Salman. Good, Salman. See, in the first part, in this circuit, 3 and 3, both these are connected in series. Yes, Khalid, good. Second one is right. So second one, all of you found it easier. It is easier than as compared to one. It's just that in one you have so many resistors connected. Now in first part, see 3 and 3, these two are connected in series. So it makes it 6 ohms. firstly you will get it. Let's say this is R1, this is R2. So R12 will be 3 plus 3, that is 6 ohms. So you replace this by a single wire, means single resistor, 6 ohm. So you can see 6 ohm and this 3 ohm, both are connected in parallel. So 6 ohm and 3 ohm. Let's name this resistor as R3. Let's say this is R3, R1, R2, and R3. So if I talk about the upper half, this was what? This was R3. Now we have 6 ohm connected. So R123 will be what? 6 into 3 divided by 6 plus 3. That will be 9 plus 9. This is 18 by 9. That is 2 ohms. Now check in this circuit. All these three are replaced by 2 ohm. So what does this triangle look like? This looks like this is 5 ohm 1. Here you had that 3 ohm 1 and now you are having the 2 ohm 1. Since wire is here, just check both of them. These two are connected in series because this is a single wire. These two are connected in series. This becomes 5 ohm. Let's name this as R4. Let's already name them R4. This one is R4. So see, now net resistance will be what? Net resistance will be, this will be 2 plus 3. That gives you 5 ohm. So you have 3, 5. It means, see, if you see the system is symmetric. If I'm solving all these wires, means all these resistors, and I'm getting, what is the value that I'm getting? I'm getting 5 ohm. Obviously, if you will solve the lower portion also, you will get again 5 ohm only. So in these kind of question, where you are able to see the symmetry, no need to solve it again. If you have seen the first half of it, it means obviously the answer for the second part will be the same. Try it again. 3 plus 3 will give 6 ohm. 6 ohms with 3 ohm in parallel gives us 2 ohms. So then 2 ohms in series with 3 ohm gives us 5 ohm again. So it's basically what? This is 5 ohm, this is 5 ohm, and this is 5 ohm. What did I tell you? Whenever you have parallel connections as identical, just divided by the number that is there. So it's like this is 5 ohm, this is also 5 ohm, and this one is also 5.
3 by 5.
Not 3 by 5, 5 by 3. Whatever is the number of resistors, not just divided by the number they are present. If they are identical, had it been 4, then you would have to do again the whole reciprocally addition of them. So it will be, yes, 5 by 3. So R equivalent of the circuit, this becomes 5 by 3 ohms. This will be the equivalent. First, note it down, or let's discuss the second part as well. See, for the second part, these are in series. So if they are in series, this becomes 15. Then 15, it means R1 and R2, both of these are for the second part. R12 becomes 10 plus, that was 5, 15 ohm. Now that this is now connected in parallel with this. If not talking about this, both these are connected in which manner? Parallel. So this was 10 and this is coming 15. So R equivalent will be 1 by R will be what? This will be 1 by 10 plus 1 by 15. So don't write R equivalent. R equivalent will show that. Write it as R123. That is better. R12, yes, because R12 and R3, these are connected in parallel. All right, so you can take this LCM, or either you can directly write the answer. are 1, 2, 3, you can directly write 15 into 10 divided by 15 plus 10, because instead of taking the LCM, it's better. So this will be what? This will be 150, and this will be what? This is 15 plus 10. This is 25. So you have ultimately, you are left with what? 150 divided by 25. So here you all can directly write the answer as 6 ohms, because here when you would have solved this reciprocally, you would have got 1 by 6 ohms. So you can directly write it as 6 ohms. Now what were the values in these two arms? 10, 15. So R equivalent will be 10 plus 15 plus 6, that makes it 31 ohm. All right, so note down these circuits you've already drawn, this one. And tell me one more thing. If you need more practice of circuits, then we'll do 1 or 2 circuits. Otherwise, then we can move on to Kirchhoff's law. So tell me, all of you tell me whatever you want. If you want more practice of circuits, we can do. And similar thing, same circuits can be replaced by capacitors. More on circuits, no? Okay, 1 or 2 questions. We'll do. No, Zaid and Shavya. Just check once again. Are equivalent across A and B point. Whenever A and B is there, no, it means they are connected with the help of a wire. So cell must be connected between A and B. Which one, Salman? First part or second part? That you have? No, no. Check again. Check again. Yes, Salman. Now it's right for the first part. Second one, no. Shavya, check again. Check again. First one, Khalid, no. Not this again. Try again. Try once more between A and B. Zed again. Zed, you check your answer once again for the first part. Khalid, now your answer is right.
Ma'am, should we use sandwich method here in first one?
In the first one, you can directly use it. Directly you can use it. Just
Okay.
check whether how all of them are connected. You are closer. Your answer is close. Just check. Slight mistake is there in your answer. Or which one's health? Which part?
First one again.
First one, no. For the second one, Salman, no, not this. Had it been a straight wire, no, then all of you would have answered the second part. It's just the wires have curved and formed into a circle, so few people are getting confused. Just think it, the wire is still a straight wire only, no? It's just that bending doesn't affect your answer. All of you know the answer for the second part at least. First part I can say yes, first part can take time. Even third and fourth part can have error. Second part, all of you know. Such kind of circuits we have already done. It's just that you're not able to identify. For the third one, no. R11 R by 4. No, not such a huge answer. Check again, Shravya, check again for the third part. Okay, so second part, Z, no, not this one. Khalid, fourth part. No, Salman, fourth part you have answered in terms of small r. Small r is not given in fourth part.
There is an error to R by mistake.
Okay, so it's 25 by 4. No, you'll get a complete whole number. You'll get a complete whole number. Just start from here. A hint to all of you for the fourth part. Start from here. First solve this circuit. First solve this circuit. Means start your calculations from here. Take 2 more minutes. Look at all the 4 circuits. At least be familiar. Try all the parts and we'll discuss them one by one. Yes, Shravya and Khalid. Yes, Shravya and Khalid. Now your answer for fourth pass is correct. I think you, Khalid, you had started from the wrong side. From here, you would have. Exactly. Zed, you have identified the method correctly, but check your answer. Your method is correct. That was what I was hinting you people. You have identified it correctly. Now see whether this will be the answer or not. I think in the first part also you did the same mistake, and in the second part also you're doing it. Okay, calculation error was there, Khalid. Oh, yes, yes. Fourth part, the answer is correctly given by Shav and Khalid. That is right. Zed, you have identified the method. You have identified the method. So if you have identified that method, see what will be the answer. The same mistake you were committing for the first part. That's why your answer for the first part was also coming wrong. Initially, you had answered it. Okay, let's do one thing. Let's discuss the first two, those circles part first, then you people can try the third and fourth part. All those who are not getting the fourth part. Someone has answered. No. Yes, now it's right. Zed, now it's correct. Did you identify your mistake? What was happening? Were you not taking the reciprocal of it or what?
Yes.
Reciprocal you were not taking, no?
Yes.
In the first part also you have done the same mistake. So I think now you know the answer of the first part also. First part also you had submitted me. It's just that you didn't take the reciprocal of it. So good. Said second part is right. See, for the first part, best method. Okay, I think Salman and Khalid had answered it correctly. Khalid did, and Salman was the first one to answer. Salman, why did you make guesses? 4R or R/4? Either it can be both of them. Be sure. Firstly, whatever will your answer, that will win.
I'm sure with R/4, like 4/R, I did calculation wrong. So
Okay, you did calculations
instead of
wrong.
reciprocal, I took the other one. So I
Okay. Then it's good. You were the first one who had answered it correctly. See, for this circle one, no, best way, not even to try that sandwich method or any method there. Best way to identify for the first one. I think Shravya, you also listen carefully. How did it look like? It was a circle. Yes, fourth part is right, Salman. These were your circuits. This is point A and this is point B. Now, whenever I see no A and B are there, it means just add a battery to it. Then you will be able to identify whether they are connected in series or parallel. So it means A is a common point. In order to see whether all the four resistors are connected in which manner, just raise A. It means if I have this resistor, this circuit with me, this circular circuit with me, if I have it, just pick it up and add it. Pick it up and add it means if I pick it from A point, means I raise it from A point, how the circuit will look like. I'll try to draw it. This will look in this manner. This will be the first one, this will be the second one, this will be the third one, and from here it will be the fourth one. This will be my pointing. See, are you able to see? Just in order to see, you don't have to draw it in this way in your exam, just to make it clear to you. If I pick it from A point and I extend it, it will look like this. Now, can you see all the four are connected at one point? Here you have to identify this is the wire now, and here is the other wire, means all the four are connected directly in parallel. And no need to even do calculations. What did I tell you? Whenever all the resistors are equal, then divided by the number of resistors that are present. How many resistors are there? 4 resistors are there. What is the value each of them is carrying? Yes, sure. Yeah. Now you understood how to do it. It will be R/4. So R equivalent will be R by 4. They were identical, so your calculations were easier. Had it been different, then you can directly add them. 1 by R, 1 plus 1 by R2 plus 1 by R3 and plus 1 by R. All right. So first one is correct. Second one, I think apart from Z, did anyone, nobody has answered. Only Z has answered the second part. See, the method that you people are not able to identify. Second one, it's just that the wires have curved, but Khalid is having network problems. If you look at carefully between A and B, I'll redraw the circuit and show it to you. This is a simple Wheatstone bridge. Remember we had done Wheatstone bridge. For the third one, no Z.
Okay.
Okay, just check once again. Not such complicated for the third one. Simple answer is there for the third one. Okay, I'll give you a hint. Since that you are trying, start from here. Then you will be able to do. Since Seth, you have already answered the second part. Others, listen. See, if the circuit has been in a curved form, it doesn't mean no that the concept will change. See, a wire is there. If I draw it in this way, then you people say this is a Wheatstone bridge. Wheatstone bridge, we have already discussed in capacitors. Yes, Khalid, now it's right. So you had to identify that it's a Wheatstone bridge. If it's a Wheatstone bridge, you have to check whether it's balanced or unbalanced. Now it's a balanced Wheatstone bridge because all of them are having the value R. Do you see this? This was RR. When it's a balanced Wheatstone bridge, the middle one, no current flows through it. In case of capacitors, we had seen that no charge flowed. In case of resistors, no current flows through it. So if no current flows through it, then we say what? You can just erase it directly. So if I draw it in this diamond shape, then you people say it's a Wheatstone bridge. If the wires get curved, then you people are not able to identify. Just look at the wire. Even if it is given you in circular form, then also it's a Wheatstone bridge. For the third one, no. What is the? I am discussing. Third one I am discussing.
Okay.
So answer for this. See, this becomes what? This will be 2R. And this will be what? This will also be 2R. 2R are connected in parallel. It means, what did I tell you? Whenever two of the resistors, these are connected in parallel, just divided by 2. So 2R divided by 2 gives what? 2 gets cancelled. R equivalent is small r. So small r was the answer for the second part. So do one thing. Is it clear, Salman, now? Wheatstone Bridge.
Yes, ma'am.
So just
Ma'am, the middle one like ignored.
it will be ignored. No current is flowing. So even if you draw no current is flowing, why will you consider it? Balanced Wheatstone bridge is there, no? In case of balanced Wheatstone, we will be doing it separately also again, Wheatstone bridge, because in Kirchhoff's law, unbalanced Wheatstone bridge we'll use. So Kirchhoff's law best example is, we will do it again. But in capacitor, remember I told you, whenever you have a balanced condition, means P by Q is equal to R by S, means R1 by R2, this is equal to R3 by R4. No current flows through it. So just erase it. These become in series and both of the resultant become in parallel. So did anyone answer the third part? I think nobody has answered the third part. Any answers of third part, then just write. No, Shravya, no. Not 9R by 2. See, for the third part, no, start from here. Start from here. This is a hint. And for those who haven't done the fourth part, start from here. 3R by 2 for the third one. No, Salman. Check again. Okay, 2 minutes, Shravya. Okay, take 2 minutes and we'll discuss. Both the parts and we'll discuss. No, third is not a Wheatstone bridge. Third cannot be a Wheatstone bridge. See, wire, you have to see the wiring. That's why A and B are always mentioned in the circuit. Whenever it's A and B, no, it means a battery is connected here like this. Whenever it's A and B, if it's A and B here, it means a battery is connected like this. So this is a Wheatstone bridge. Do mention in your notebooks. This is a Wheatstone bridge. That's why I was saying you, all of you have done this. It's just that the curving of wire confused you. Zaid, did you again try the fourth part?
Yes.
You tried it. What answer are you getting?
Just doing.
Okay, just write me your answer, whatever you answer you're getting. I'm not able to find your answer of the fourth part. Again incorrect, Salman. Not R by 2. R by 2 is the answer of this. Answer of this. This is R by 2. Means both of them. Not R equivalent. Let's discuss the fourth part first. Because third part most of you are trying. See, these two are what? These two are connected in parallel. If these two are connected in parallel, this makes it 5. So see how the circuit will look like. First, I'm discussing the fourth part because most of you have answered it correctly. See, this was 10, this was 10, this was 10. This will be 5 now because 10 and 10 both have become 5. Now, if you see both of them, this becomes what? This becomes 15. So basically, this is this circuit 10, 15, 10. Now you can see 10 and 15 are again connected in parallel. So our 10 and 15 becomes what? 10 into 15 by 10 plus 15. That gives 150 by 25. You can write it as 6. So this is 10 and 6 connected in series. So R equivalent becomes 10 plus 6, which is 16 for the fourth part.
Ma'am, could you show the third one again, please?
Okay, figure of third one. No, Shravya. Answer is right. Yes, Shravya. Finally, correct answer. Shravya, good. Third part is right. Z 30 by 11 for fourth part. No, 16 ohm. 16 ohm must be the answer. So, Shravya, did you understand now? Alright. That was your last try, Salman.
Yes.
Still no. Still the answer is incorrect, Salman. Khalid's network issue isn't letting him come in. Ravya did answer, and Zaid is still trying. And Salman has given up. See, let's discuss it now. Khalid's network issue is not getting fixed. See, if this is R by 2, this will also be R by 2 or not? Salman.
Yes, ma'am. That will be R by 2, and the down one also will be R by 2.
Then, where's the issue?
Adding like either reciprocal, or I'm confused about that.
See, all of you, both of these will be R by 2, these will be R by 2, and this will also be R by 2. Now see, how does the circuit look like? Now, once you've put in R by 2, this is for the third part. So, this is now R by 2. So R by 2, R by 2, and this is what? This is also R by 2. So you have R by 2 connected, and so two resistance along each side are parallel. That's why you got R by 2. So a resistance in these arms are connected in series. These are connected in series. This was your point A and this was your point B. So if I say this is 1, this is 2, this is 3. So R12 will be what? R12 will be simply R by 2 plus R by 2. This gives what? 2R by 2, that is R. Yes, that will be small r. Now see, R by 2 and small r. These are connected in which manner? These are connected in parallel, A and B. So small r and R by 2, these are connected in parallel. Yes, Zed, are you answering something?
Yes, ma'am. 3 by R is the answer.
3 by R, Zed.
Yeah,
Again.
3 by. Sorry.
Again,
R by 3, R by 3,
R by 3. R by 3. Zed always forgets to take the reciprocal. In all the parts, 4 by R, 1 by R. It will be R by 3. The correct answer is R by 3. Good. Salman, understood?
Yes, ma'am. I didn't like make it again, the diagram.
Okay. Whenever you're solving these circuits, no, as you keep on solving it, try to redraw it because the unnecessary resistances get eliminated. Khalid, your network issue is fine now. Are you able to hear us? No. Okay. Khalid is having network issues. So this is what these are connected in parallel. So this will be R multiplied by R by 2 divided by R plus R. That is R by 3. So R by 3 is the correct answer. Zaid, in your exams, don't forget to take the reciprocal of it.
Yes.
So note it down.
I got confused with like the wire that joins down, right, to the smaller triangle. I got confused with that.
This one, no? This one. See, that's
No,
why
no, no,
here,
not that
this
one.
one.
Not that one. No. Like the triangle apart from there, it's joining the smaller triangle down.
Okay, this one, where it is joining this. Okay, in the main figure.
Yeah, in the main figure.
Here, this one, no?
Yeah.